All right. So we're going to start with sigma notations. In my college classes that I'm taking, this sigma notation is one of the most outstanding, most amazing, uh, I would say, chapters in math. The concept is having the sum of infinite numbers equal to some finite number. It introduces the idea of limit. We have to learn what a sequence is first. So right here we notice that we have 2, 4, 6, 8, 10, 12, 14, 16, and 18. This is a finite sequence consisting of positive even integers less than 20. And right here we got 3, 6, 9, 12, 15, 18. This is an infinitive sequence consisting of the multiples of 3. The multiples of 3, it's an infinitive sequence. Well, because we can write it as 3 times 6 is 18, and that will be equals to 6, right? So the number 6, this number is the number of the sequence. This is what we want to pay attention for, the 6, because 3 times 7 it's 21. So it's the 7th number in the sequence. Use it. So let's consider adding fractions in the following manner. We have 1/2. This is equals to 1/2, right? Okay. So if we add 1/2 plus 1/4, we'll get, what is it? You have to have a same common denominator. So you multiply here by 2, and you multiply here by 2. This is 2. So this is, now that you have a common denominator, you have 4, 4, 1, 2. So it will be 3/4. And we have to keep going. So if we add 1/2 plus 1/4 plus 1/8, it will be 7/8, because we had to get the same denominator. So this is 2, this is 2, it will be 7. Okay, let's keep going. So we can keep doing this. 1/2 plus 1/4 plus 1/8 plus 1/16. And this will be equals to 15/16. Now, if you look at this, it seems that it is just so it's almost 1. An infinity sequence, or a sequence, is a function with the positive integer is the domain. Note, a finite sequence will be so indicated. The word sequence used alone indicates an infinite sequence. Consider the function Let's do it here. Consider the function 1/2 n, where n is any positive integer for this function. So let's do function of 1. Remember that we are adding in infinity numbers, so we're doing 1, 2, 3, 4, 5. So let's see what we get. 1, 2 over 1 will be 1/2. Let's keep going. F function of 2 will be 1. This will be 2, 1/4. F of 3 will be 1 over 2 over 3, 1/8. And to the 4, this will be to 1/16. Or we can write it this way as a function. So this is right, this is the x, the n number n. Remember, the number n will be substituted to x like an x function. So this will be 1, 2, 3, 4. We can write it this way also. The general term is called the n number term of the sequence. The entire sequence can be denoted by writing the n term in braces as a number of, so it will be, so here in braces we have a as a sub n. This this sub this sub number on the bottom, it's it is used to in matrices to call the numbers or to reference the number. This will be like 811, 812, 813, and so on. So if we keep going down, we will call this subs 821, 822, 823. So let's review some examples so that we can really understand what we are talking about. Okay, so if they tell us write the first three terms of the sequence, remember that the terms, number terms, we is the is this letter, right? Is the term n. So we can all right. So if they ask us to do the three terms of the first three terms of the sequence, we will do this. So what's supposed to be a third? All right. Let's do another problem. So we got B, and they ask us to find B1, B2, B3, B sub 15. So we can call this the first B. This, well, B, it will be correctly like B sub 1, b sub 2, b sub 3, b sub 15. So we can do here as a b1, b sub 1. Look, I'm just copying directly from here. This is 2 times 1 minus 1. This will be equals to 1. B sub 2, 2 times 2 minus 1 will be equal to 3. B sub 3, 2 times 3 minus 1, 5. B sub 15, 20. 2 times 50 minus 1, 99. They could also ask us to find the general formula of the sequence. So it will be kind of like the inverse. Okay, so we have to really pay attention to the numbers. We have 3, 5, 7, 9, and 11. So think about it. Let's think of a formula that by adding an infinity number, we can get those numbers back. If we insert those numbers subsequently, like 1, 2, 3, 4, 5, we will get those numbers. So if we do like 2, remember we bring the terms, and if we add plus 1, n sub 1 will be as 2 plus 1 equals 3. Look, we have n sub 2, 2 times 2 equals 5. 3 times 3 plus 1, 7 to the 4th. 2 times 4 plus 1 equals 9 to the sub 5, 11. Let's think about 0, 3, 8, 15, and 24. Now, this is kind of hard if you think about it. But let's break it down. We have 0, 2, 8, 15, 24. So we can start by writing n plus 1. Well, it will be minus 1, I'm sorry. If we do 4 minus 1 will be 3. That doesn't, but if let's say if we do square n sub 1, 1 square minus 1 equals 0. 1 square, 1 sub 2, 2 plus 1, 3. Sub 3, 3 square, 9 minus 1, 8. If we do 4 square minus 1, 16 minus 1, 15. 5 square minus 1, 25 minus 1, 24. So Last thing, last thing that we want to talk about sequences. It could go down or up. It can increase or decrease. In subscript notation, the term a sub n plus 1 is the term following a sub n. In this term is found by substituting n plus 1 for n. In the formula for the term, for example, if a sub n is equals to 1 over 3 n, normal n, then a sub n plus 1 will replace the n, not as a sub, but as a normal number. As you can see, 1, 3, 3n plus 3 plus 3. Similarly, would be b n n squared. So if this is then b is n plus 1 as a sub. We have this n plus 1 square because we're substituting n with this, and this n has a square. So how to identify a decrease sequence? Well, if the decrease sequence, this one, it's larger than what we are putting, then it's smaller. But if if the if this term is the first term, it's smaller than what we are putting, what are the numbers increasing, then it becomes larger. Let's do one example. Let's do if b sub n it's equals to n plus 3. It's increasing, okay? So we can write it, we can start beginning by right, b sub n is equals to n plus 3, and b sub n plus 1, so we can write this as n plus 1 plus 3, right? Because we're substituting the n with this. Now if we do the addition, we get n plus 4. This is what I want to point. N plus 3, it's smaller than n plus 4. And this is the first term, and this is, with the exchange. So this is an increase sequencing. Let's do another one. So we have a n sub n is equal to 1 over 2 to the power of n. Okay, and we can say this is decreasing. Okay, decreasing. You get the idea. So we can start by writing the an and by writing the a sub n plus 1. All right, we have 1 square 1 over 2 we substitute the n plus the n plus 1. Okay, this will give us, if we do the calculation, will be 2 times 2 times n. And this 2 times 2 n to the n power, if we don't have to do, we can just compare it right away, that this one, sorry, this 2n is smaller than this 2n plus 1. Just look at it. N plus 1, 1, 2, n. So therefore, we can write this 2n is larger than 2n plus 1, because an is, we, there you go. So the sequence is decreasing. The last, we will use a sequence that is neither increasing nor decreasing. So we can start by writing C n, it's equals to 2 plus minus 1 n, the power of m. So we can write here by sub 1, sub 2, sub 3. Let's just do, and we can add it. So this will be 2 plus minus 1 to the 1 power. 2 plus or minus 1 to the second power. 2 plus minus 1 to the third power. This will be equals to 1. This will be equals to, now if you square a negative number, it will be positive. So it will be 3. And this is another law. In logarithms, there is this term when we use the negative 1, and 1. And all of this, just keep the pattern. Okay? So if we use odd numbers like 1, 3, 5, if we power like negative 1 to the third power, we will always get a negative number like this, like a negative 1. But if we use like 2, 4, 6, so on, like the powers of 2, we always gonna get a positive number, 1. And in this case, it's equals to square minus negative 1. And this negative would be, because if you consider this would be negative 1, if we square this, we get negative 1. If we square it again, we will get a positive. If we square it 4 times, we will get a negative So if we keep doing this, now we start with the C4. We continue with the C4. 2 plus minus 1 to the 4 power. Guess what? It's 3. Because this is 2, 4, 6, 8, 10. We always get a positive number. So this will be 1 plus 2, 3. So as you can see, we are stuck in a pattern. 1, 3, 1, 3, 1, 3. So we are not increasing, not decreasing, just like going up, going down, going up, going down, going down.